In the past, a CPU was the processing element for a computer. CPU stands for Central Processing Unit, and CPUs were commonly referred to as processors. Later, multiple CPUs were incorporated into a node. Now, individual CPUs have multiple cores, and each of those cores is a processing element. CPUs with multiple cores are called processors. So what we have now is that a node contains one or more processors, and each processor has multiple cores. In our documentation for Henry II, we refer to a node having multiple processors, each having multiple cores. The software definitions can be confusing too and might vary depending on who you talk to. A job consists of everything you write in a script and submit to LSF. When you run a job, you are doing tasks. You could do one or several tasks. The tasks can be related, but they don't have to be. If the work to be done by a task can be broken up into smaller pieces, those pieces are called threads. Tasks are sometimes called processes, and these terms can be used interchangeably. At the end of the day, the thing we want you to understand is how to request resources for your job. Here's a diagram of a single node. The node has multiple cores, it has memory that is shared by all the cores, and it has a small amount of disk space. The nodes communicate with each other through a network. You submit a job with LSF, and if the job is a parallel job, it can be broken up into tasks or threads. You need to reserve one core for each task or thread. The network is the hardware that allows the two nodes to communicate, but the software that allows this communication is called MPI, or Message Passing Interface. If you or whoever wrote your application did not program the code to use MPI, your code cannot communicate over the network. Without MPI, the cores on one node cannot access the memory of another node. That means that all of the tasks must be confined to one node, where they all have access to the same memory. They share the memory. Parallel jobs that can only make use of one node are called shared memory jobs. If your code was written with MPI, the task can be distributed across multiple nodes because the memory used by the application can be distributed across nodes. Parallel jobs that can use multiple nodes are called distributed memory jobs. The next optional specifier is B sub -R span. The span specifier tells LSF how to arrange the cores over the nodes. The options are to specify that all the cores must be on a single node with hosts equal 1. The next option is that you can specify how many cores per node with p-tile. When running a distributed memory job, request n according to the number of MPI tasks or processes. MPI jobs need to set the MPI environment and they need to use MPI run. That means you should be loading a module that has MPI, and you need to add MPI run before calling the application. You also may want to specify the span, which means specifying the number of tasks to put on each node. There are two reasons why you might want to specify p-tile. The first reason to limit the number of MPI tasks per node is because each task takes a lot of memory. The second reason could be that you are running a hybrid code where MPI tasks may spawn threads.